All right, we are ready to go and
Yeah.
we are live. Let me
Okay.
make sure that
Thank you.
everything else is operational and working on my side, and make sure that people are, now joining us because we have different time zones,
Yeah.
lots of different time zones coming in.
Yeah. Excellent.
So we would have people coming in from, well, it's 5 a.m. on my side, so that's a
Oh,
little bit early.
oh la 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 la. I I feel so sorry for you, Sanya. So you will.
Oh, that is all good. All good.
I hope you have some strong Caribbean coffee out of Trinidad. So
We do have a lot of good coffee in
I'm
Trinidad.
sure. I'm sure
We
about that.
do.
Um,
Coffee and chocolates. Two
Coffee
of
and
the best,
chocolate. Yeah. Yeah.
two of the best things in life.
As as long as you don't take too much of it,
Oh my gosh, yes.
it's like
Yes.
antioxidants in lubricants. Too much is also
Yes.
not good. So
Oh my God. Yeah. Yeah. Yep. That's
okay.
definitely it because you can't anything in life within moderation. Definitely within moderation. But we do have like some of the best chocolates though. Like I would just say hands down. So I will give some people a little bit of time to join in because I know, you know, getting and navigating your way to this is always interesting on the morning off.
Yeah.
But for those of us who are joining in, just let us know where you're joining in from, what's going on your side, what time it is. Let us know what time it is, because that's always a good place to start. I know it's like half of your day has already gone on your side, you.
Yeah.
So,
Yeah.
yeah,
It's
I'm still
uh
getting
yeah.
started.
Yes, it's I think maybe some people from Asia. I know
Ah,
I had a few
yes.
emails from asking for Asia, but um and so it's normally Greg was going to be also on this
Ah,
presentation, but he's tied up in some other meeting. So
Greg
he
is a
tr-
busy guy.
he trusted me for today to make the presentation. So
Oh, yay.
I will take his full trust and not abuse his trust, like we say.
Oh my gosh, yeah. Oh boy. So I know
Uh,
Aaron is saying that it is 12:02. So
ah,
I think that's midnight.
oh wow.
Thank you for staying up with us. We
Yeah,
appreciate that a lot. Definitely appreciate that a lot. Because I know it's it's not easy going in.
no, no. Okay,
So
I
I
think.
think we can
Yeah,
probably try and get started.
yeah,
So I know, like today, we're going to talk all about lubrication case studies that reduce the operational risk. And time and time again, we have all of these things within the industry, and we're always trying to be a little bit more safety compliant. How do we reduce some of the risk for our guys and girls on the ground, because safety is very important. It's at the core of everything that we try to do. And when you start thinking about the lubrication aspect, there are a lot of different safety things that come into place, like just, on a regular basis going through your lubrication routes. Like there are things that you can do to actually reduce some of the risk that you may have, you know, on a plant, on a facility, when you're trying to get a get a very, I want to say a nice HSE number, but a very low HSE number, because nobody wants to have accidents, nobody want to have lost time injuries. So we're trying to figure out, and in this session today, you will guide us on ways that we could actually reduce some of the risk that we may have for, within our facilities. So I'm going to pass it over in very capable hands of you, and you're going to take us through some ways to reduce some operational risk, because it's a lot of good information that we should have and things that we could put into practice right away. Very low hanging fruit. So that's always good. So off to you, you.
Thank you so much, Sanya.
You're
And
welcome.
as usual, you always make this very kind introductions and learning introductions. You're totally right. Also, would like to thank Greg Livingstone, who helped me
Yes.
making up this presentation. So that is, like I say, always important to know that you have good colleagues helping you with this training
Yes.
sessions. Also, these are recorded sessions. They can be heard afterwards if you want to listen it again. To welcome everybody, making time today for listening to a good 25, 30 minutes on the subject that just Sanya informed us about. And yes, not just by coincidence. It is a period who is approaching July, August, which in Europe specifically is a period where there's a lot of maintenance actions planned, revisions, some outages, especially in refinery and chemical applications. So we thought that it would be interesting to talk about how today with applications, lubrication applications, how you can highlight the risk avoidance to these improved lubrication strategies. And it's not only sustainability or reliability, but also safety, who will, just like Sanya told us in the introduction. And the outline of this session today is will make you a brief introduction to RBM, risk-based maintenance. I apologize if I use this abbreviation, but if now we know when we talk about RBM, it's not RCM, but it's RBM. So just not to confuse you, but
Yeah.
uh,
Always good to know.
yeah. And that, of course, it's always best with theory than to combine with
Mhm.
practice. So we will go over three specific active case studies on heat transfer fluids, then the benefit of real-time oil condition monitoring as part of risk avoidance, and then, absolutely, we all know the heart of Fluid Tech is the Fill for Life strategies, extending oil life, which is also a very good example of RBM strategies. Now, if you look a little bit on literature and trying to understand the word risk, what it means, um, then it's interesting that when you look at formulas or description, that it is a product of the combination of the probability of the failure combined, multiplied by the consequence of the failure. And for those who are football fans, we know we have today a lot of European games going on. Just imagine that you are in the last minutes of your game and you have to kick a penalty. Put yourself in the position of that football player who has to kick the penalty. Well, there is a probability of failure for him, which, of course, through training he improves that, and the probability will be very low of failure. But what goes to the head of this guy in front of the keeper is the consequence of the failure. Um, and that is, I think, a good way to understand why we how we can configure it and describe risk. But even to better describe, this is the picture of, you can see this rock climbing athletes, amazing shots hanging on that rock. What is the risk of this free soloing rock climbing without a rope? Well, I think imagine that it has to do with the height. If he's taking at a low height, well then okay, the probability is going to be low to having an injury. Also, the consequence will be very low. I mean, he will still be able to jump on his feet, but if he is very high, then absolutely there's a higher probability, and most important, the consequence will be pretty high for this person if he doesn't have a rope to as a safety action. So RBM or risk-based maintenance, we can describe three main parameters, or I would say conditions. Um, First of all, let's look at it in the context of maintenance. It prioritizes maintenance resources, and we know that resources in plants, maintenance resources, are very valuable. They're not always available. That's why sometimes maintenance actions or maintenance people are outsourced. But it's clear that the resources that you need to prioritize towards an asset uh, um, that carry, in most cases, a high risk if they were to fail. And that's why in a lot of chemical plants they divide the equipment in different levels of criticality, and of course it's going to be important in function of the criticality that you prioritize maintenance resources. It's also a matter of using the most economical application of the maintenance resources. Make sure that the tasks they have that they can perform them in the best conditions based on their skills, um, and um, and it's clear that we need to make sure that these efforts are optimized. And through the presentation, you will see that this will come back. These three, I would say, base rules of risk-based maintenance for your different assets. And you heard me talking about asset criticality, and this is what we call this criticality matrix. We see on the left side the different categories. So you're going to rank the severity across multiple categories. The severity is on top. You can see 5 categories from minor to catastrophic. And then you will see on the left side the five different categories. And once again, it's more than just cost. I see too many times when I'm in the plant, they focus on making sure that they're going to be within budget and within budget for their maintenance interaction. But yes, there's also environmental aspects. Just think about if you have some pollution occurring. Think about your wind turbine in the middle of the sea. Production, if you have a minor stoppage until an extensive stop, for I would say a critical compressor who is delivering a gas which is used further in the plant. Maintenance equipment damage also, which can go from minor damage to destruction. And let's be very honest, we all know that an intervention or a maintenance action and opening an equipment means that you open equipment is always containing a certain amount of risk. So avoiding to open it is, of course, reducing significantly the risk. Um, so that is why in this matrix you can assess criticality with probability, and so that means that companies what can they benefit the most from this risk-based asset maintenance? Well, first of all, imagine that you have what I already told you just on the other slide, that you have categories of high-risk machinery. Um, fast rotating gas compressor, or maybe just a very special pump gearbox. So it's clear that you need to look at and categorize this high risk machinery and prioritize the maintenance resources. Or maybe companies that are using very expensive machines. And if you look at today investments for turbines, gas turbines, steam turbines, even pumps can go for quite high amounts. And then last but not least, which I believe is today a very hot topic, it is the limitation of maintenance resources. Not only having the competences, but also the staff. Uh, for example, in July, August, people are like in Europe take vacation. Are you going to be sure you will have the right maintenance resources available? So you need to optimize also these efforts across the team of your maintenance. And that has, of course, because that's what we talk about today. Yeah, we talk about lubricant case studies. What is the impact on the lubricant decision? That means if you have this RBM and you prioritize, you make this matrix of actions, this RBM plan with dedicated resources. Um, that means that they will need the most attention from your reliability engineers with a program, with objectives, with specific tasks. And lubrication tasks include here, that means in advance talk about the flushing, the oil changes, other strategies, oil analysis, condition monitoring. So that is all tasks that part of this RBM plan that you create and where you can then also relate specific loop strategies and decisions once again to reduce that risk. And it's part of the probability, yes, of course, but also what we know the impact it will have on possible production and other aspects. Just, of course, this is very industry dependent. It's clear. If we look at refineries versus nuclear plant, which is working in steady state power conditions, versus a chemical plant with varying operating conditions, it is different. So it will also need a different plan. So based on that, for a lubrication engineer, making sure that you collect machine data and in advance, oil analysis report, operating machine data, temperature, bearing temperatures, vibration data, then evaluate possible risks of failure with its consequences, then you rank them, you make your RBM plan, in team. This is a teamwork. It's clear that you have people from health and safety, maintenance, plant management, logistics, and you evaluate, and possibly you can then repeat them for future operations, optimize them. But clearly, the collection of data in advance, and that's why often interventions for equipment, it started 2-3 years in advance of a major revision. But it also applies for an unplanned revision, which is usually taking only like 2 or 3 days. So that was a 50 minutes introduction on RBM, which I hope it clarifies you what we understand by this risk-based maintenance. So that we have now selected 3 case studies which we thought would be of interest to prove this RBM strategies. And the first one is heat transfer systems, which is once again very widely spread in different industries. But we took here an application of asphalt plants, where the situation is that they change this large oil system every year with the flushing, and as you can imagine, it takes once you talk about oil changes and flushing, for those who are in maintenance on this presentation, that it's significant time and labor bounded, with, of course, once again, risks. And in this heat transfer, well, it's fluids which are extremely hot. They're working up to 300 degrees and higher. So there's a safety risks with that. HNS, health and safety, the environmental risk with chance of oil spilling during the flushing and the cleaning of the system recharging. It is, we know, it is specialized business with specialized resources. And last but not least, the risk as I say, every time you open a system, you have the risk of contaminating the system. And in this case, it can be contaminated with flammable contaminants working at very high temperature, or even in some cases, some residuals of the flushing oil. So there is certainly, and we know that we all, I mean, I've been too long in business that too many times you go to a plant and they say, yes, it's always been like that, and we know the risks, and we know the risk of an oil change. Uh, we know it, but meanwhile, it is clear that there's factors that you cannot uh, always evaluate, and it's important that you do that. And for example, here, the system, if it becomes thermally imbalanced, meaning that you have not done the oil change correctly, then it will impact production. So in the case of fluids, heat transfer fluids, which are degrading and reducing viscosity, having a lower flash point, then at that time you can either go for an unplanned outage, which is a high risk, but there's a risk of finding a new solution which is lower than the risk of the unplanned outage. And that's what we evaluated. In this case, we have um, looked at a solution which is called the solubility enhancer technology, which I will introduce you in the next slides. But in this case, the risk that we were quantifying to defend this proposal was um, the potential fire hazard, incompatibility was being avoided, deposit transfer, and it's clear that there were risks that if you had to change an oil, that could be avoided. That's why we have decided to apply solvency enhancement. It's called, in this case, this is a case study based on Mobile Solvencer, but the Mobile Solvencer is a co-branded product from Fluidtex through Mobile Corporation, and it's based on our Decon technology. And if you look at the risks then, and then opposes to what we propose, well, the fire hazard, no, there's no fire hazard. The product is approved above 300 degrees C. Incompatibility is voided also because it's the solvency technology is 100% compatible with base oils from group 1 to 4. In this case, it's a mineral fluid that we have done the intervention. Risk of deposits. Well, that's an improvement we do with solvency enhancement. We are going to dissolve these deposits, and there's certainly no risk of further deposit transferred into the system. And is there any other risk by applying the solvency technology? Well, it's a chemical solution, proven technology, but of course, we are not going to be able to fix the mechanical problem. Imagine that one of the pumps of the heat transfer system is in severe wear because of deposits. Yes, it's clear that that pump is being weared out too far. You cannot resolve that. But from an aspect of risk reduction, well, it will be very low. That's clear. And here we see how the 5% solvency enhancement was injected from the pails during operation into the system to restore, and that's important, the thermal balance. I repeat, by thermal balance is that during degradation of these heat transfer fluids, you're creating components which are based from a cracking process, a thermal degradation process, and they are have a lower volatility. So that means that the thermal balance is I would say affected. By restoring this, we had not only an increase of plant capacity because you were able to cool more the fluid, the system. That's important. It's a heat transfer fluid. But also we had, because of the lack of deposits on the internal tubings of the heat transfer, we had 20% decrease in fuel consumption. And today, knowing the prices and also the impact on CO2, this is from a sustainability and economical viewpoint a big advantage. No hot oil breakdowns. Like I told you, usually these are resulting in pump wear. Uh, and for the maintenance crew, they were very happy because I can tell you, for them it was a much lower activity of maintenance, lower costs, um, rather than to have to clean manually pumps or injection pipes, which is, I can tell you, and for those of you on this presentation that know about heat transfer, it's time-consuming activity. Finally, on this asphalt plant, the risk was very low now because the plant skipped the oil change, is running for another year, and that will probably be longer than 1 year because the solvency enhancement is not degrading. It's a continuous process, keeping activity. Um, and now we are also now we're going to add to other heat transfer systems this solvency enhancement just to avoid further maintenance issues. So there was a first case to highlight you how you can approach it from a risk-based approach to improvement in lubrication strategy. Another case study was very interesting. This is an industrial gas turbine at a U.S. university where yes, the oil sampling was performed very regularly, and still they had an outage which was unplanned and occurred. And here our approach was to this program to reduce the risk and the probability of failure is to work towards online sensors to mitigate the failure. And so this is very unique. I think this is the first time we present this public, this data. And when we look at the oil analysis trend, which is the viscosity here, together with asset number, you can see how this university did a very regular oil analysis. You can't be better in frequency. Unfortunately, what we noticed that there was a missing parameter which was not measured. That was the antioxidants. So when we did the antioxidant analysis, we noticed that the oil was depleted of antioxidants. RPVOT was less than 30 minutes. Um, and when we did root cause analysis through infrared, we noticed that there was a small coolant contamination. And in fact, it's a combination of the glycol and the water, which reacted with some of the oil and degradation products and created rapid polymerization of the oil, creating this high viscosity increase. And so the criticality of this turbine clearly very high, and the costs of it, the impact of this downtime is also very high. And the plant did everything they should have done. Unfortunately, the missing parameter was the antioxidants. Could have done have They could have done included in the oil analysis, but here the approach we make is to reduce the risk here of possible failure and being a critical application, there's a presentation of the cost of the inline sensor, and which is, of course, higher than the cost of oil analysis. That is clear. But if you approach it again in this RBM matrix, the cost of the inline sensor will still far below the cost of a downtime. And so the inline sensor, which was presented here, justified absolutely any future downtime. And let me tell you, it's not only a matter of cost. Once again, it was the risk here that we wanted to keep under control. And when we looked at this turbine oil, we can clearly see when we simulated this same oil, went through an oxidation testing, a lab testing, it was confirmed because you could see how the MPC trend was showing an opposite trend versus the antioxidant depletion. So clearly, the two major parameters that were needed for monitoring this oil would be oxidation by varnish, but also very important, the depletion trend of the individual antioxidants, being here aminic and phenolic antioxidants over a 12-week time, which is of course quite excessively at 120 degrees C. It's a significant stress time, but antioxidant depletion would be a very good criteria to monitor. And when we went to sensor selection, we built up this matrix of different sensors today available from molecular analysis, where we look at either the capacity or the electric constant, impedance spectroscopy, mid-infrared analysis to look at the molecular bounds of, for example, antioxidants or degradation products. On the other side, you see the gray graphs are the more focused on wear particulate analysis, either by magnetic flux or laser particle counter. And then on the left side, you see all the abilities to which the technologies would have to correspond with its weight. For example, let's look at ability to measure antioxidants. We put a weight of 4 because it's proven that it was important from the oxidation testing, or oxidation testing is also of 5. Wear metals, we put a 1 because wear did not occur here as a major degradation mechanism. If we then look at those 5 different sensors, we can see that when we attribute and the total points in this sensor selection matrix, we can see that, for example, the sensor based on mid-infrared, which taking the mid-infrared spectrum to look at specifically antioxidants, oxidation products, you can see that, yeah, that's weighted very highly. And of course, we are not the mid-infrared is not performing well for wear metals, but of course it's not weighted very high. So at the end, it's clear that the sensor selection based on mid-infrared outperformed other sensors for this application, and it optimized to measure both amines, phenols online, as well oil oxidation and solvent content, with some typical graphs you can see here for the mid-infrared zone. So the risk of this catastrophic failure that has been significantly reduced just by combining sensor with also laboratory results on this gas turbine. The last 5 minutes is my case study number 3, which is a case study that we have been able to share with ExxonMobil company from one of their assets using a propylene refrigeration compressor on lube oil lifetime extension. What do we understand by that? It's basically, let's look a little bit at the background. This is a critical compressor with commissioned 2012 and using an ISO VG46 quarterly monitored on a volume, and which is quite significant because it's a drive line for this motor compressor and coupling, 36,000 liters. And operating conditions show that the condition of the train was healthy, and the oil analysis was also done regularly. But the oil analysis showed that there was an indication of, I would say, depleting antioxidant additives. Was that the motivation to change your lubricant? Well, if you look at it from a risk perspective, risk avoidance, you would say, no, let's not try to change the lubricant, because opening such a critical equipment with 36,000 liters of oil, I would not do that. Are there any other options? Well, yes, there's other options. And we looked at all the different risks, compatibility, safety, operational. Think about the system flushing, which was going to be a high risk activity on this compressor. So, but doing nothing, well, that's also not good because it's clear that the base oil was too heavily degraded. So, after assessing this risk factor, the plant decided that re-advertising with antioxidants um, would bring the compatibility risk, safety, and operational risk to nearly zero, um, and or at least extremely low, just by adding fresh antioxidants to the system. And we did first the simulation testing to confirm compatibility versus ASTM standards, and then also estimate performance. That means performance is how are these fresh antioxidants that you add, will they react synergetically? And yes, it was confirmed that adding the AO to this in-service compressor train, I repeat, this is done with the compressor oil or the compressor in service, no need to stop by using this mixture of antioxidant in the solvency enhancer with a risk which was much lower than oil failure, of course, and also important an oil change. Um, and here we can see how we did versus HTM standard tier 1 to tier 4. All testing parameters up to RPVOT, rust prevention, copper prevention. It is from these test matrix, Deconeo was determined to be 100% compatible and restoring, and that's important, the oil performance to the quality of a new oil. And that is, I think, very unique. So in this case, the Deconeo was after the testing added, of course, with a very strong oil analysis program and some data I select for you. Asset number was reduced to an acceptable level. We also had look at the MPC dropping from 20 to 4 just because solubility enhancement and mostly important aminic antioxidants they brought to level to even better than the new oil, to 100% and better. Um, you will ask yourself, how is the oil now? Well, 2 years later, um, the oil condition is still very stable, no issue at all to the equipment reliability, and yes, on cost savings, you can see the number here, quite significant high number. I'm not even assessing the risk here, which is really zero. There was no impact at all. And today also, when we talk about health and safety, sustainability, well, CO2 savings here are also here estimated at 30,000 kilograms CO2 savings per year. So here we are with the last slide. It's clear that for people who are in lubrication strategies and have to make decisions related to lubricant, RBM is certainly a very useful tool and widely used, supplying solutions to not only critical machines, but it's currently surely it will justify corrective actions rather than related to oil changing and flushing. And it will impact not only risks but also operating costs. And technologies at Fluidtech that are aligned with these lubrication strategies with lower operating risk and can integrate it from now into RBM strategies are, of course, extending the lifetime of your lubricants, restoring system performance. For example, in the first case, heat transfer systems, we think about hydraulics, wind turbines, anymore. Provide online monitoring in critical assets. And then, of course, at the end of the day, reduce your turnaround maintenance with limited resources and lowering carbon footprint in um, industries just like power generation or refineries. Sanya, I'm through my slides, 2 minutes longer than planned, but I hope this was learning for all attendees, and here we are. So
Oh, yes. I think, first of all, thank you so much for going through these slides and giving us some more context in terms of what we can expect with risk for the lubrication system. Because I think once we have any sort of system being operational, we often forget about the risk involved, and we forget that there are bigger impacts to what we can and cannot do. I'm gonna. Do you want me to? I could remove your stuff from the
yeah,
show if you want.
I'm
Yeah,
I'm there. Yeah, yeah.
yeah,
I
it's
just
all
I
good.
was thinking the same. Yeah, thank you.
All good, all good.
Uh,
But you did a great job in terms of helping us to understand why we have so much operational risk involved in simply changing of an oil, or understanding if we had some sort of degradation happening. Because I think that's where we have a lot of, I want to say, hesitancy. And we think that there's no risk involved when we start doing these changes, or if we're monitoring the oil and we start seeing these, totally decreased antioxidants or your MPC levels going up. We don't really understand fully the amount of operational risk that can, result from not acting on it. So I'm so glad that you brought that point up, especially for the heat exchangers, because that's an area that we forget about, and we think, they should be fine. You know, there's not much involved with heat exchangers, but there is quite a significant amount of risk involved with heat exchangers. So I'm glad that you brought that up for us this morning, and giving us something to think about, a lot to think about. Because there are, and I think I lost you for a bit. These gearboxes or turbines, involved in all of these different situations. So what will happen is that you may actually see a difference in terms of you know, your cost savings that you're gonna get. So just something to think about. Thank you so much for your time this morning, you. I think we lost him for a little bit, but if you have any questions, just reach out to us. Yo is more than happy to take some of those questions and help you answer however he can, as best as he can, to reduce some of that operational risk that you may see happening in your equipment. So thank you so much for your time this morning, and we'll see you again soon. Bye.